This video is going to highlight an enhanced spacetype report user script for OpenStudio 0.6, as well as show a new script that allows you to select spaces and see the loads associated with those. So right now I just switched to the render by spacetype, and in some other videos we've discussed the info tool, which you can drag over and see basic information about the spaces if you're in the correct rendering mode. You can also open the inspector, and when you select a space you can see the space types, but again you don't see the loads, you just see information about the space types. To see the loads, you actually need to go to either the OpenStudio space load objects to look at lighting or gas or electric, or the definitions. So there's a little bit of jumping around to do that. And so originally we developed this report to make it easy to get a quick analysis of your project by going to the user scripts and to the write space type report. It generates a CSV file. I'm going to overwrite the one I have, and I'm going to open that in Excel. So this has a summary of your building in a number of ways. At first is the entire building, and then you have lighting, power, density, electric, people over to the right, as well as floor area and your default space type. Then we summarize by building story, by space type, but what I'm interested in is a summary by space, which is actually sorted by space type. So I have all of the banquet, the corridor, the guest rooms together. So for example, here I can see that I have 4,400 square feet of guest rooms. There are 4 total spaces, and then if I want to see the details on those 4 spaces, they're here. So I can see what thermal zone they're on, what story they're on, the floor area of each one individually, lighting, power density, electric equipment, and then people. So this is just a sample script, but you could customize this to show the data you want in whatever units you would like to see them in. And if you wanted to sort this differently, then you could just select and sort, for example, by the name of the space rather than the space type. So what this doesn't tell me, though, is what loads actually go into the file or the object to get this particular lighting power density. And so what you can do in SketchUp now is select one or more spaces, and I'm just going to select one space just to make this easier. So I'm going to select a guest room, and I'm going to go to a new script, which is report space loads. And before I do that, actually, I'm going to open my Ruby console, and I'm going to make it kind of large so we'll be able to see this a little better. So what this does is it is a report for the space named space 5, and it inherits loads from its space type, which is the guest room. And so that has a people object, a lights object, electrical equipment, infiltration, and ventilation. Now, we could have had multiple light objects. In our templates, we tend to use lighting power densities or equipment densities, like a watt per square foot, where in a more detailed project you might have 50, or rather 20 50 watt lights, and then 10 watt task lights. And so you have multiple types of the lights and multiple types of equipment in there. And it tells you an instance of the object as well as a definition. So for example, if you're using real objects instead of densities, you might have a definition of a Panasonic TV, 42-inch TV, but then the instance of that carries possibly a multiplier of how many of them you have, as well as a schedule that shows the usage of that object for this particular space type or this space. So another thing we can do that we don't have here is this direct space children. So in addition to a space having loads associated through its space type, you can individually add spaces, or rather individually add loads on top of that. So if we had any, they'd be listed below here. And again, I could run this with multiple spaces, select it, and if you wanted to have these exported out to a CSV file or a text file, you could just modify the script to print the data to a file rather than to the Ruby console. So that's all I wanted to cover here. I'm just showing another way you can kind of do pre-simulation analysis to see that you're in line with your program, or to look for any anomalies in the data that you might have set up for your file before you run your simulation.